Hello everyone, and welcome to this tutorial session where we're going to look at the independent samples t-test. So the independent samples t-test is also a test used for comparing means. So the independent samples t-test. Now we use the independent samples t-test where we want to compare two groups. So we can actually look at it in this way. So we have x, we have y, that's our test variable, which is normally numeric, continuous. And then we have this variable which is categorical. That's one way of looking at it. Another way to look at this is, in fact, that we have our sample of size n, and then we have our two groups n1 and n2, and what we are going to then do is to compare the mean values, right? So in this case we're going to calculate x bar 1 and x bar 2, and what we are actually interested in is mu1 and mu2. So we use the independent samples t-test when we are dealing with two independent groups. It could be a group of students and then you have male and female, or it could be something like we have organizations and then you have public and private. It depends on the study you're carrying out, but the idea is that you can actually consider the two groups really separately. So let's go through this and actually look at how to perform the test using SPSS. But let's do that in the context of an example. So let us say we have a research question, which is simply, is there a difference between the average height of boys and girls, and let's say in the context of University of Mauritius students. So what's going to be our hypothesis? So H note would be there is no difference between the average height of boys and girls at UM. Let's write it this way here. And H1 will be there is a difference between the average height of boys and girls at UM. What does this represent? This basically represents that mu1 minus mu2, or you can say the average for boys minus average for girls, is equal to 0. And here we're saying mu boy minus mu girls is not equal to 0. Average height represented by mu. So where mu represent, mu b represent average height boys at UM, and mu g represents average height of girls at UM. Okay. So here we're saying there's no difference. Okay, so mu b is equal to mu g, or mu b, the mean height of boys at UM minus the mean height of girls at UM is equal to 0. No difference. And here we're saying that there is a difference, mu b minus mu g not equal to 0. And that's what we're saying here. So that's of course our assumption, the null hypothesis, and that's the alternate hypothesis, the claim that we are making. Okay, so suppose a study was done and we collected a sample of 70 students. We collected data from a sample of 70 students. And now we're going to run the test and see how to interpret the results. So what we do now, we're going to perform the test using SPSS, and as we're going to see, it's quite straightforward. We'll just go on analyze, compare means, and we choose independent samples t-test. Okay, so let's do that. Okay, so let's carry out the test. So let me switch now to our software. Yeah, and well, suppose that's our data set. So we have here a sample of 70 students, right? And we are now going to so we're now going to run the test. So we go on analyze, compare means, independent samples t-test. So now, so let's say that's the variable we're looking at. So height, 21 years old, and then we have gender, which is our independent variable in a way, referred to as grouping variable here. So we select gender, and so we need to define the groups just like how we coded them previously. So we need to specify this again. So we click on define groups. So we had coded male as 0 and female as 1. So that's basically cover group 1 and group 2. And we say continue. Just make sure that here 95% is selected. That should be the default. And we are good to go. So we click on OK and we get the results. So here we get the results of the independent samples t-test. So what I'm going to do now, I'm going to copy those output. So let's take that, copy, and let's place it here. I should paste it first. Okay, so here we are. And okay. So what do we get in terms of results here? So first, let's look at the descriptive statistics. So we see that that's our estimated mean value. So of course, what we have in terms of results, we have estimated mean. So for boys, male students, we get a mean value of 172.56 centimeters. And for girls, we get a mean value of 155.85 centimeters. So of course, looking at the results here, we have a difference, and the difference, as we can see here, is 16.703. So based on our samples, so the study we have carried out, the sample of 70, we get here our estimated mean values. So x bar b, sorry, represents the mean value, average height, mean value, it is average height of boys. at U1. U1 is X bar G represent the mean value or the average of average height of girls at U1. Well, we should actually say estimated. That's the most important thing actually. Estimated mean value. That's the key thing here. Estimated mean value. Not the real mean value, but the estimated mean value. Of course, our hypothesis refers to what would be the true mean value, and that's why we perform the independent sample t-test, isn't it? So based on our estimates, based on our sample of 70, we find that there is a difference, but we want to know whether this result is likely to be true or not. So for this, we look at the independent samples t-test. Now, one thing to note is that when we get the output from our SPSS software, it actually includes the Levene's test for equality of variances. Now, there are actually two assumptions that need to be tested whenever we do an independent samples t-test. As is the case for all parametric tests, you need first to test for normality, even though we should bear in mind that when we have a very large sample size, it's okay, even if our distribution is not normally actually doesn't follow normality. Having said that, it's always good to check for normality, because otherwise the mean might be a biased measure of central tendency to start with, and you don't want that. And that could be an indication that there are outliers, and that's also something you need to do as preliminary test. But other than normality, we have the assumption of equality of variances, and this is included here. So if you look at this part of the results, that's actually the test for equality of variances, this part here. So that's not the t-test, that's actually the test for equality of variances. So this first thing, you need to just have a side note here, okay, and then we'll come back to the independent sample t-test. So we have the assumption of equality of variances, also referred to as homogeneity of variances. And this is the test we do here. We just verify whether we can assume equal variances or not. So for this test, our H note, for the assumption test, our H note is that there is no difference between variances. What we're referring here is actually here the variance, when we can look the standard deviation here. So the variance being the square root, or rather I should say the standard deviation to the square, rather, the variance. So we are actually testing this assumption, and we want to see roughly equal variances. They need not be the same, but they should not be there should not be a large difference between them, you see. So H note is that there is no difference between variances, and H1 is there is a difference between variances. Between variances of what? Variances of the two groups, of height, regards to height for the two groups. So that's what we're looking at here. So how do you interpret that result? So obviously here you look at the significance value. So, and in this case, since the significance value or p-value is equal to 0.132, which is actually greater than 0.05, right? So basically here we do not reject H note. And what do you conclude? But there's no difference between variances. In other words, equal variances can be assumed. Okay, no differences between variances, no significant differences. Therefore, we can assume equal variances, right? So what's the implication here? Given that equal variances can be assumed, we're going to interpret this first row here. Okay, so we'll not be concerned with those results. We'll only be concerned with the results of the first row where we assume equal variances. Okay, so that's it. That's an additional step that you need to just look at before interpreting the main results of a t-test. Okay, so now we're good to proceed with interpretation of the main results, the independent samples t-test. And here we are. So we get a t-value of, so you can write the degrees of freedom, t-value of 9.537, which is quite large. Significance value, p-value, 0.000, less than 0.05. I think that's straightforward. What do we do? Therefore, we reject H node. We are much evidence against H node. Coming to our hypothesis, so we can reject H node, right? Because we have a significance value here, much less than 0.05. Good. So now we're ready to report the results. So we can proceed, and I'll just give you an example of what you can write when it comes to the interpretation of the independent samples t-test. Okay, so interpretation and reporting. Interpretation and reporting of the results. So in a nutshell, what we've looked at, so we can say that the average height of male students, so m is equal to, what was the average for male? 172.56. What was the average for female? 155.85. And then standard deviation 8.617 for female, 5.636, and 36 sample 36 for male, 34 for female. So that's what you can write here. So 172.56, standard deviation of 8.62, yes, from any sample of 36. So this average height of male students was hypothesized to be different. So that's what we claim, our alternate hypothesis, from the height of female students, and where we get actually from our sample a mean value of 155.85, a standard deviation of 5.64, and a sample of 34. Now, the observed difference, based on the sample data, we observe a difference. So, observed difference of 16.70 centimeters was found to be statistically significant, right, at the 5% level of significance. And you can report it. T degrees of freedom 68 is equal to 9.9, p is equal to 0.000, which is less than 0.05, right? And that's it. Now, we have an additional step which you want to include in your interpretation of results is, so we always want to include what we refer to as the uh, effect size. So this result here, this result here, this tells us about the statistical significance of a result. But what we want to also look at is the practical significance of a result. So for the practical significance of a result, we want to calculate a relevant effect size. So we're going to do that right now. So let's just look at an online sample size calculator. So let me just use this one, for example. There are many of those, and it's not difficult, by the way, to calculate those, but we have nice online calculators. So you need here to choose one which corresponds. So here we had equality of variances assumed, so that's the one we need. Coens D2 sample, that's actually the one you need here. For the independent sample t-test, where the assumption of equality of variances has been met. Okay, so it requires us now to input the sample mean for each group. So it was 172.56 for male. For female, it was 155.85. Sample size for male was 36. Sample size for female was 34. Standard deviation for male was 8.62. Standard deviation for female was 5.64. So here we are, and we can now calculate the Cohen's D. That's what we want as our effect size. And let's see, it hasn't calculated it yet. Let me click on calculate again. What's happening? Oops. Just bear with me 1 second, since what there is a slight issue with this here. Okay, so I should probably write this again. So let's do that. Let's do that quickly. 172.56, 155.85. Sample size 36, sample size 34, 8.62 standard deviation, and 5.64 standard deviation. Hopefully it works. That's good, perfect. So we get a Cohen's D value of 2.28, which is quite large. So it tells you here it exceeds Cohen's convention for a large effect. These go to 2.28. Let's remember that and just write it here. So we get a Cohen's D value of 2.28. Now, generally speaking, a Cohen's D value, if you get a Cohen's D value of around 0.2, that's considered small. A Cohen's D value around 0.5 is considered to be medium, and around 0.8 is considered large. So we get something which is larger than 0.8 here, so we have a large effect. Okay. So that's something we want to include in our interpretation here. So we might want to say something like that the difference in height between boys and girls, of course, is found to represent a large effect. So here, of course, we are looking at the difference between the estimated means and not the real means, which we don't know about, the estimated means. But that's important to look at this again. Okay. So that's what we're saying here. All right. So we can actually conclude, what can we actually conclude? We can conclude that on average, it can be concluded that on average male students are taller than female students at the University of Mauritius. All right, so that's basically what you can conclude. That was 2-8, non? Parce que j'ai écrit 2, 9 ici. C'est ça. And we're done with our independent sample status. So I hope you enjoyed this tutorial session and that everything is clear for you. See you then. Bye bye.